given a power function f of x is equal to k times x to the power of n, where n is a non-negative integer, we want to identify the n behavior. Step number 1, we determine whether the power is even or odd. Step number 2, we then determine whether the constant is positive or negative. And then number 3, we're going to use the figure to identify the n behavior. So for example number 2, we're identifying the n behavior of a power function. So describe the n behavior of the graph of f of x is equal to x to the 8th power. So first thing we need to identify is what is the leading coefficient of this function? Well, the coefficient is 1, so we have a positive coefficient. So we determine that. Now we need to determine what is the exponent of the power function. Well, the exponent of the power function is 8, and it's an even number. So we know that the power is even. Okay, so now what we're going to do is we need to figure out, okay, what's happening on the graph. So let's take a look. So now, as we look at the x-axis here, as x approaches positive infinity, okay, what can we say about the function? Well, that's also approaching positive infinity. So we can see that as x is approaching positive infinity, we can see that f of x is approaching positive infinity as well. Now, as x is approaching negative infinity, we can see that the function is approaching positive infinity. Okay. Now, the one thing that we need to also pay attention to is that it says here that the function is increasing without bond. Or it also says the output is increasing without bond. And the reason why is because these arrows mean that it never ends. So the without bond means that it's continuous and it never ends. So these arrows are basically telling you that it's increasing without bond.